Good morning, everyone. Today we will start with Chapter 7, Circular Motion and Gravitation. Section 1, it's about circular motion. First of all, what is the meaning of circular motion? From its name, circular motion, it means like an object moving like in a circle, right? And we know that every circle has a center. So, any object that rotates or moves around a specific center, we say that this object undergoes circular motion. Like here, this example, we have children that are going in this merry-go-round, so they are rotating around a specific center, around a single axis. So we say that here these children undergo circular motion. Okay, so the line about which the rotation occurs is called axis of rotation. So here is the center. The axis that passes through the center is called axis of rotation. Okay. Here another example. So also these children are going in circular motion because they are moving around a center, specific center here. Okay. Here another example. Here there is a very simple example. Let's say that we have a ball which is attached to a string and it's moving in a circle. Okay, so this ball, since it's moving, for sure it has a speed. We know every moving object has a speed. Plus direction. When we have speed and direction, we talk about something called velocity, right? Velocity, which is the vector quantity. Okay, what means vector quantity? Any quantity that has direction, we say it's vector quantity, right? Okay, so this ball has velocity. If we want to draw the direction of this velocity, how to draw it? We draw it like this, because at this position exactly, it was moving in this way. Okay, but when the ball, for example, reaches this place, at this position the ball was moving how? It was moving like this. When the ball reaches this point, so the ball, how is it moving? It's moving like this. Okay, so we say that this line, it is what? This line, we call it tangent to the circle. What means tangent? Tangent, I will remind you about its meaning. It's like the parallel line to the circle at this point. Okay, so when the ball reaches this point, if I want to talk about its velocity at this point exactly, how is it going, the ball at this point? At this point the ball is going like this. Okay, at this point the ball is going like this. So at every point during the path, during the circular motion, the object or the direction of the velocity of the object is tangent to the circular path. So the velocity vector is always what? Tangential to the circular path. So this is the direction of the velocity. Once you have circular motion, the direction of the object in this circular motion, it's always tangent to the circular path. Okay, so speed is magnitude, is just value of the velocity, and maybe the speed of this ball, it may be constant. Maybe the ball is moving with 2 meters per second. Okay, so the speed is constant, is not changing the value, the magnitude. Okay, but the direction here, as you can see, at every second, at every point during this path, the direction changes. Okay, so here see how the direction of the velocity, see here how. So for sure at every point during this circular motion, the velocity the direction changes. So since the direction changes, what we say, the velocity, is it constant? No, because velocity is again speed and direction. Even though the speed is constant, if the direction changes, what happens for the velocity? The velocity changes. This is from the first chapter you took in this year. Okay, So since velocity is a vector with both magnitude and direction, we see that the direction of the velocity is always changing. Okay, so velocity is changing. Okay, anyway, so what do we call this velocity? This velocity, we call it tangential velocity, as its direction is drawn always how tangent to the circle. So if I give you an object and I ask you to draw its the velocity at this moment, you just bring a ruler and you make it parallel to the circle at this point. Okay, so always the direction of the velocity of an object is tangent to the circular path. Okay, tangential speed, so we represent it or we write it as v and subscript t, okay, of an object in circular motion is the object's speed along an imaginary line drawn tangent to the circular path. So when the tangential speed is constant, the motion described is called not only circular motion, is called uniform circular motion. So actually in this lesson we will deal with uniform circular motion. So what means uniform circular motion? Again with me, if the ball is moving with constant speed like 2 meters per second all the time, so the circular motion of the ball is called uniform circular motion. Okay, because it's not changing the speed, the value, the amount of the speed, but for sure definitely the direction is changing, therefore the velocity, which is the vector quantity, is changing. Okay, the last point here, pay attention on it. The tangential speed depends on distance from the object to the center of the circular path. Yes, for sure. What is the speed? You took it in the first chapter in this year. Speed is always the distance divided by time. So when you have more distance, the speed will change. Okay? So they are saying that this speed, which is tangential speed, it depends on the distance from the object to the center of the circular path. Here an example. How would the tangential speed of a horse near the center of a carousel so compare to one near the edge? This, for example, a horse near edge, and here a horse near center. What do you think? Which one is covering, or which one? Yes, which one is covering more distance when moving in circular motion? For sure, the one where near the edge. Okay, so which one has more speed here, this horse or this horse? For sure, which one? Just wait. Okay. So okay, so this one for sure has what? More speed, because it's covering more distance. So see, because the distance from it to the center is more than the distance from this horse to the center. So whenever the distance increases, it means the speed will increase. Okay, so we know, girls, that the horse near the edge has a greater speed because it must travel a greater distance, 2 pi r. What means 2 pi r? Do you know what is it? It is the circumference of the circle. So you know the circumference in circle in math is 2 pi times the radius of this circle. So that's why I said before that whenever the radius increases, whenever the distance from the center to the object increases, the speed will for sure increase also, because when the radius increases, it means the circumference or the distance covered by the object will increase. Okay, so whenever you go farther from the center, you are going to cover more distance in a circular motion. More distance gives you more speed. Okay, So the horse near the edge has greater speed because it must travel a greater distance in the same amount of time. Tangential speed is simply, we can say, instead of saying distance over time, what is the distance? It is the circumference here, because we are talking specifically about circular motion, and all objects are going to cover circles. Okay, so tangential speed is simply the circumference divided by a period of time, the time required to complete one rotation or one revolution. Okay. Tangential speed. So speed is always tangent to the circle. Uniform circular motion, what does it mean? The value of the speed has a constant value. What it changes, therefore, only the direction it changes. Example shown to the right. So here the ball was here, okay? The ball is moving with constant speed, but the direction it changes at B. See how was it and how it becomes, okay? So always the direction of the velocity is tangent to the circle. Okay. Centripetal acceleration. So we talked, girls, first a keyword we talked about it in this lesson was tangential speed. Okay, now we will talk about a second important thing, which is centripetal acceleration. Okay, so acceleration, let's revise together the meaning of acceleration. We know that acceleration is the change in velocity in a period of time. Okay, it means to have acceleration. In order to have acceleration, we must have change in velocity. If the velocity isn't changing, therefore no acceleration, right or no? Okay, here in our examples about uniform circular motion, do we have acceleration or no? What do you think? For sure we have. Why? Because the velocity of the object in a circular motion is changing even though it has the same speed. We said any object that is moving in circular motion, its velocity will change due to the change in direction. So acceleration is change in velocity, size, or direction. This is the definition. And the direction of velocity changes continuously for uniform circular motion. So even though the circular motion is uniform, even though the circular motion, the speed is constant, this is the meaning, but the velocity is changing because the direction of the object is changing every second. Okay, so we have acceleration. The acceleration of an object moving in a circular path and at a constant speed is due to what? Is due to change in direction. An acceleration of this nature, what do we call it? We call it centripetal acceleration. We will see why it's called centripetal. Centripetal, from its name, okay, it means century, it means center. Petal, it means seeking. Actually, it is a Latin word. So centripetal, it means this acceleration, it's center seeking. So it's direction toward the center. We will prove that. See here, we have the same example, a ball moving in a circular path. The ball here has this direction of velocity. At point B, it has this direction. Okay, what is acceleration? Together, we know that acceleration is what? Acceleration is V final minus V initial over time. Okay, this is V final, this is V initial. So if I want to add vectors, we know that V is velocity and velocity is a vector. So see, girls, I have V initial like this and V final how? like this, right? Okay, so I want to add these. How to add them? V final, this is V final. Okay, I will take it first. So this is V final minus V initial. See V initial how it is. It's going this direction, but because we are subtracting V initial, and I want negative V initial, I don't want to add V initial. So you remember vector properties, when we want to subtract a vector, we add its opposite. We add its opposite. So this is V negative V initial. So when you want to V final minus V initial, it is the same as what? It is the same as V final plus minus V initial. Okay? When you want to subtract a vector, you add its opposite. Okay, so this is V final and this is negative Vi. Always we place the factors head to tail, remember? So and then at the end the resultant, how is it? See girls, this is a better drawing. So this is V final and we add its opposite, which is negative Vi. Okay, the resultant, it's drawn always from where to where? From the tip of the first till the head of the last. So this is what this is delta V. Okay, which is what? Which is V final minus V initial. So this is delta V, and delta V, it gives you the direction of what? Of acceleration, because acceleration, it's equal to delta V over time, right or no? Delta V over time. So the direction of delta V is the same direction of acceleration. So the direction of acceleration is how? Is always toward the center. See, the ball is moving like this, and we found that the direction of the acceleration is down here, so it's down where? Toward the center. So what direction is the acceleration? It has the same direction of delta V, and we proved that delta V is going toward the center, so always the acceleration is going toward the center of the circle. That's why we said it's centripetal acceleration. Centripetal means center seeking. Okay, so see here, if you have a ball on a circular path and you want to add the directions of velocity and acceleration, how to add them? Velocity, we said that it's always tangent to the circle at the point that we are talking about. Acceleration, it's always directed toward the center. This is the center here. Okay. Okay. So centripetal acceleration, how to find it? We always follow this equation. So AC, it means, so this C, it is the subscript for centripetal. So this means centripetal acceleration. It's equal to Vt. What means Vt? It is the tangential speed. Why it's called tangential? Because it's tangent to the circle. Okay, Vt, the magnitude of Vt, the value of Vt squared over r. What is r? R is the radius of our circle. Okay, so always we follow this equation in order to find the centripetal equation. So it means the centripetal equation, it's proportional to two quantities. What are they? The first quantity is the tangential speed. Okay, when the tangential speed increase, for sure the centripetal acceleration increase. It's like girls, if you are for sure example of a ball. Okay, if you attach a ball to a string and you are moving the ball faster and faster, so for sure here the ball will what? Will accelerate more. Okay, so the acceleration will increase. When you increase the speed, the acceleration also will increase. Okay, if the speed is multiplied by 2, how will the acceleration increase? Will it be multiplied by 2? No, it will be multiplied by 4, because here tangential speed squared. So if v is multiplied by 2 squared 4, right? Okay, so this is the first factor. The second factor is the radius. When you increase the radius, the ball is here, so when you increase the radius, the acceleration will what? Will decrease of the ball. So radius and acceleration are inversely proportional. When you decrease the radius, and the ball is moving like this, so the acceleration will increase. Okay, we'll see this one later. Okay, the last part for today is tangential acceleration. Usually we will not use it a lot, so but we have to know the meaning of it. What is tangential acceleration? Already, girls, we talked about centripetal acceleration, which is the most important thing in this lesson. Tangential acceleration is when the speed of the object changes. See, you have seen that centripetal acceleration results from what? From change in direction. We said that centripetal acceleration is due to what? Is it due to change in direction? Okay? In circular motion, an acceleration due to change in speed is called tangential acceleration. Why it's called tangential acceleration? Because this type of acceleration will be drawn how? Tangent to the circle. To understand the difference between centripetal and tangential acceleration, consider a car traveling in circular track. Because the car is moving in a circle, the car for sure definitely it has centripetal component of acceleration because its direction is changing. So whenever the direction of an object changes, follow me. So whenever the direction of the object changes, its velocity changes. Okay, so it has acceleration. This acceleration is called centripetal. So the acceleration that results from change in direction, it's called centripetal, because as I showed you, girls, if you make it using vector addition, you will find that its direction toward the center. Second point here, if the car's speed changes, the car also will have an acceleration called tangential acceleration. I will not go in the details of this one, okay, because we will talk about centripetal more in this lesson. So this is everything for today.